We've seen that the first derivative tells us where a function is increasing or decreasing and where it has local maxes and mins. Today, we're going to learn what the second derivative tells us about a function. And before we do that, let's consider two functions that are increasing, but look a little different. So I could look at this function that's increasing everywhere. And I could look at that graph. It is also increasing everywhere. But we notice these two graphs look different. And that's what the second derivative is going to tell us. We're going to say that the one on the left here is concave down. I think because it's kind of like curving downward. I think of this, if I poured rain on top of it, the rain would fall off. We say that this graph is concave up. If I poured rain into it, it would kind of stay in the bowl there. So this kind of curves up. So what is it that the second derivative tells us here? So if we look at slopes of lines on each of these graphs, slope starts really tall here. And then the slopes are getting shallower here. So we start with big slopes and then we get smaller slopes. And so the slope of the tangent lines are decreasing. And so the slope of the tangent lines are decreasing. Decreasing means I need to look at the derivative. So the slopes are derivatives though as well. So this is essentially saying that the derivative of the derivative, it has to be negative because the steepness of the slopes is decreasing. So concave down functions have the second derivative being negative. Concave up functions have the second derivative being positive. Okay, and so this is our test for concavity. If the second derivative is positive, then the function is concave up. If the second derivative is negative, then the function is concave down. I like these little smiley faces here. So 2 plus signs, the second derivative, that's what the 2's are. If they're positive, then the function's concave up. Concave up functions look like smiley faces. If the second derivative, so 2 negative signs, if the second derivative is negative, the function's concave down things look like frowny faces. Okay, so the way that we're going to start doing these is going to look very similar to what we did for increasing, decreasing, except for we're going to do the second derivative and a sign chart for that. So let's find the second derivative here. So first derivative is 15x to the fourth minus 15x squared. So the second derivative then will be 60x cubed minus 30x. We're going to do a sign chart for the second derivative now, just like we did sign charts for the first derivative before. So make sure you label your sign chart. This is why I said we needed to label our sign charts before, because now we're going to have sign charts for both f prime and f double prime. And so we need to find where the second derivative is 0 or does not exist. Let's factor out a 30x here. So we'll have 2x squared minus 1. This will be 0 when x is 0. So we get one place on our number line. This will be 0 when 2x squared is 1. So when x squared is 1/2. If I take the square root of both sides, I get plus or minus root 1/2. So I have negative 1 over root 2 and positive 1 over root 2. These numbers are negative 0.707 and positive 0.707. Okay, now we're going to plug numbers in each interval into the second derivative. We're plugging things into the second derivative because this number line, everything about this number line should come from the second derivative. So let's plug numbers into this kind of slightly factored form. A number smaller than negative 0.707 would be like -1. 30 times -1 is negative. -1 squared times 2 minus 1 is positive. So we'll get a negative number here. Let's try negative 0.5. 30 times negative 0.5 is negative. 2 times negative 0.5 minus 1 is negative. So this will give me a positive. I'm going to let you guys check some other numbers here, but I'm going to get, I got a minus and then a plus. Okay, so this is everything about the second derivative. The second derivative tells us concavity. So our function will be concave up when f double prime is positive. So that's going to be here and here. So that'll be from -1 over root 2 to 0, and from 1 over root 2 to positive infinity. And then concave down from negative infinity to -1 over root 2, and then 0 to 1, positive 1 over root 2. Okay. The places where the second derivative equals 0 are not called critical numbers. They are potential inflection points. So inflection points are places where our function changes concavity. So this is where the function changes concavity, so it changes from concave up to concave down or vice versa. So this is the same thing as saying that the second derivative changes signs. So our inflection points here, the sign changes at -1/2 or -1/√2, at 0, and at 1/2. If we had a sign chart for the second derivative that looks something like this, plus, plus, minus, then 0 would not be considered an inflection point, only 1 would be because there's a sign change there. Okay, it's a little different than critical numbers because critical numbers, we don't care about the sign change. Okay, you should try this next one on your own, and I'll go ahead and record it in another video.